Hi guys, welcome back to today's video. So in today's video, we'll be looking at the second order differential equation. So we have to find the particular solution to the given second order differential equation. So to solve this problem is very easy and straightforward. So let's not waste much of our time talking. Let's dive into action. So the first step we are going to be applying to solve this problem, we are going to be splitting this differential equation into two parts. We are going to first deal with the homogeneous part, then we'll deal with the non-homogeneous part later. So now let's step one now. Let's solve the homogeneous part. So we'll be solving the homogeneous equation, that is the differential equation, the y prime prime minus 2y prime plus 36y equals to 0. So we'll be looking at that, we'll be solving it. So we'll turn that into a characteristic equation. So all we just need to do is replace the y prime with r. So then we are good to go. Then we will solve it like a normal quadratic equation that we do know very well. So now it will be r squared minus 2r plus 36 is equals to 0. Then we factorize this equation. That will give us r minus c squared is equals to 0. Then our r is going to be equals to 6. So as you can see, it will be, it's square, so then it will be 6 twice. So this is a repeated root. So this characteristic equation gives birth to a repeated root. Then we know that for a repeated root now, we have the general solution for a repeated root. So that will be on y is equals to a, that is a and b are constant in this aspect, are arbitrary constant. So that will give us yh prime is equals to a exponential 60 plus b t exponential 60. So this is the general solution for the homogeneous part. You see that this is very straightforward. This homogeneous part, all time waiting, convert the differential equation to quadratic, then we solve quadratically, then we are good to go. Then we apply it in the general solution. So now a and b are arbitrary constants, like we all know, and then the exponential that came up is the general solution. That's the general solution for homogeneous part. So this y of t is equals to a exponential 60 plus bt exponential 60 is the general solution for this characteristic equation. So now that we are done with the homogeneous part, now let's solve the non-homogeneous part now. But then to solve that, we'll be applying what we call the variation of parameters. So that will lead us to step 2. So this is where A and B are the arbitrary constants. So now step 2 now, let's set up our variation of parameters so that we'll be able to find the particular solution, which is actually what we are looking for. So now to solve this now, so we have yt, that is yp, that is the particular solution of y, which is the function u1 times our y1 plus function u2 times our y2, where our y1 and y2 are, their y1 is equal to t exponential 60 and y2 is equal to t exponential 60. So that is it. And then our u1 and u2 are the functions. So these are the functions that make up the particular solution of this problem. So now what we just need to do is, we know what our y1 and our y2 is. We know that from our particular solution. Then what we need to get next is our u1 and u2. Then we combine everything using this YP formula, then we are good to go. So to solve our U1 and U2 now, we are going to be applying what we call the Worschian function. We are going to be applying the Worschian method to solve our U1 and U2. So before we can solve U1 and U2, so let's get our Worschian. So now our Worschian now, so that will be function U1 and U2. So then our Worschian function now. All we just need to do is find determinant of the matrix that consists of y1, y2, y1 prime, and y2 prime. So y1 and y2, we all know that from the general solution. Then y1 prime and y2 prime are the derivatives of y1 and y2 respectively. So that is this. We know that the derivative of exponential 60 is 6 times exponential 60, and derivative of t exponential 60, that's product rule. Then you add it up. So now it's straightforward. So now let's get our WT now, our whole scan. So now solving for the determinant. So that will give us exponential 12t after solving for everything. Yes. And we was exponential 12t. So that will be our WT. So that is our whole scan now. So then don't forget the non-homogeneous part, that is exponential 60 ln t. So our g of t is equal to exponential 60 ln t. Then so now we have gotten our word scan. The next thing for us to do on our agenda is to, don't forget, we are trying to get our U1 and U2. So now to get our U1 and U2, we need the word scan function that we have just gotten now. I've gotten our WT. So now let's get our U1. To get our U1, we have to apply the formula, or well, we know a formula for the derivative, which is derivative U prime of 1 is equals to minus y2 times g of t over the wt. So in putting that, we get our u prime 1 to be minus t times ln t. So this is our u prime 1. So we have gotten our u prime, that is the derivative of u1. So to get our u1 now, all we need to do is to just integrate our u prime 1. So that will be it for u1. So let's as well get the derivative of u2 as well. Derivative of u2 is y1 times g of t all over wt. So in putting our values now, so we have our u2 to be ln t, that is the derivative of u2 is ln t. So we have gotten our derivative of u1 and derivative of u2. So let's just integrate both u prime 1 and u prime 2 to get our u1 and u2. So that will be step 3 now. Integrate u prime 1 and u prime 2 to get our u1 and u2 respectively. So let's try to integrate our u prime 1. So that will be integral t ln t. So to do this, we'll be applying IBP, that is integration by part. Very straight and easy. So let our u be ln t, then our dv is t dt. So then we'll apply the integration by part formula, which gives us the integral t ln t is equal to half t squared ln t minus 1 over 4 t squared. So that's applying the IBP formula. So then our u1 now, we are putting, we have a minus in front before, so just integrate the minus, use to multiply our half t squared in t minus 1 over 4 t squared. So that's before that. So now that we have gotten our u1, so the next thing for us to get is our u2. After that, we go back to our yp formula and start everything. So for our u2 is straightforward. Our u2 is a very popular function, the integral of ln t, which is t ln t minus t. So that solves it for our u2. So now step 4 is to form the particular solution itself. After getting all our u1, u2, and we know our y1 and y2 from the homogeneous solution we did earlier. So now recall our yp, function from our yp, which is u1 times y1 plus u2 times y2. So all we just need to do is plug in the values that we have gotten. So that will be our yp now, that is the particular solution, is minus half t square ln t plus 1 over 4 t square times exponential 60 plus t ln t minus t, then times t exponential 60. So that will be multiplying and adding it. So that will give us exponential 60 outside. This is very common. Then minus half t square ln t plus 1 over 4 t square. So with that, combine like times, then add it up inside the bracket. So we are left with yp at this particular solution is now exponential 60 times 1 over 2 times t squared ln t minus 3 over 4 t squared. So this brings us to the end of today's video. So thank you very much. Please like and subscribe.